0, 2, it's 1 over 4, 1 over 2, it's not 0 here. When you put 0 there, it's 1, the y-intercept, and then we are putting 1 there. We are putting 1, that's 1 over 2, put 2, it's 1 over 4. This is 4 and 2. It will be like that. Therefore, x, when you look at x there, y is decreasing. So that's how our function will be looking like. That's the function of g. After reflection, the y-intercept is the same. 0 is to 1. When x is equal to 1, y is equal to 1 over 2. There is the point. When x is equal to 2, y is that. When x is equal to negative that is 2, and then 4. And then 4. Negative 2 is to 4. G. Right. When you look here, if x is positive as an exponent, our graph is increasing. This is a check x equals to exponent x. Exponent is positive, our graph is increasing. After reflection, after we have reflected about this line, our graph now is decreasing. The graph of G is now decreasing. Which means after reflection, if the graph was increasing, after reflection it will be a decreasing function. It's either it was reflected about the x-axis or the y-axis, but it will change from increasing to decreasing, or from decreasing to increasing. Right, let's now find the inverse. The inverse. Inverse of exponential function. The inverse. Right. Go. And then let's say we are having f at x is equal to 2 exponent x. And we are to find the inverse of this function. Remember, for the inverse, we swap the points. But before we swap the points, we need to change y, that f at x, and write it as y. 2 exponent x. And then after that, we swap the points. X is equal to 2 exponent y. This is the inverse. That's the inverse. And then, to find the equation of the inverse, we make y the subject of the formula. Therefore, to make y the subject, we are going to apply log. We introduce the log. So this will be log 2 exponent y is equal to log x. And then we multiply there by y like that. So this will be y log 2 is equal to log x. We solve for y so that it will be the subject. We divide by log 2. We divide by log 2. Therefore, our y will be equal to log x. Remember that we've got log 2 as a denominator there, so we just write 2 as the base. So it's log x base 2. That's what our equation, or that's how our equation will be looking like. Right here, remember that our y here, our y must be greater than 0 here. For this to exist, our y must be greater than 0. So since this is the inverse, you put x there. So for the inverse equation, x must be positive, like that. X must be positive. Let's sketch the graph of the inverse. Let's sketch the graph of the inverse. So our inverse is given by y equals, or it's x equals, x is equal to 2 exponent y. We use our inverse to sketch the graph. We use our inverse. No. We use our inverse, so we swap the points. Y is 2x. That's the inverse. It's negative 2, negative 1, 0, 1, 2. So when we are to put negative 2 there, x will be equal to 1 over 4, 1 over 2, 0, 2, 4. Let's sketch the graph. It's negative 1, negative 2, 1, 2. Right. If y is equal to negative 2, y is equal to negative 2, x is equal to 1 over 4. 1 over 4. So 1 over 4 is somewhere there. If y is equal to negative 1, x is equal to 1 over 2. That's half. That's half. Somewhere there. Negative 1 is to 1 over 2. Right? If our y is 0, no, this can't be, it's 1. It's 1. Because if you are to put 0 there, it's 1. So our x is 1. If our y is 1, our y is 1, our x is 2. If our y is 2, our x is 4. There it goes. And then we join the points. That's how our inverse will be looking like. This is the inverse of f. So remember that when you are writing the inverse, you indicate it like that. We've got 4 is to 2. We've got 2 is to 1. 1 is to 0, and then negative 1 is to 1 over 2, negative 2, it's not negative 1, x is positive, so it's 1 over 2 is to negative 1. And then here it's 1 over 4 is to negative 2. So when we look at this function again, x is increasing, also y is increasing. That's an increasing function. This is an increasing function. So, which means if the function is increasing, this is an increasing function. If the function is increasing, also its inverse will be increasing. If the function is increasing, also its inverse will be increasing. Right, let's check for a decreasing function. G at x is equal to 2 exponent minus x. Let's find the inverse again. Y is equal to 2 exponent minus x. Remember, this will be our base if we are to write the inverse. We swap the points. X is equal to 2 exponent negative y. This is our base. So to make this the subject, we'll have to introduce the logs. So this will be negative y log. It's negative y log. It's not negative y log. Let's just introduce logs. It's a log x equals log 2 like that. So we are multiplying by negative y. So it's log 2 equals log x. We divide. Minus y will be equal to log x base 2. And then we multiply by that negative to this. Therefore, our y will be equal to negative log x base 2. That's how our inverse will be looking like. It's y equals log x base 2, negative log x base 2. So to sketch the graph of the inverse again, we use that. Our base here, our base is 1 over 2, remember. Our base there. 2 exponent minus x is the same as 1 over 2 exponent that. So that means this equation can also be written as, this equation, it can be written as x is equal to, if we are to write this as 1 over 2, it's 1 over 2 exponent y. Remember, this is our base, our exponent. So our y will be equal to log x, the base, is 1 over 2. That's why we are having this. How to find that negative? It's a log x base 1 over 2. Let's write it where there is a space. It's log x base 1 over 2. This is the same as log x over log 1 over 2, remember. So log x over log 2 exponent minus 1. We are changing that as that. So this is the same as log x negative 1 times 1. That would be negative log 2.